Now, putting it all together, here's a query that uses all the single table constructs we've seen so far. Select s.department, average s.gpa, and count star from students S, where s.gender equals F, group by s.department, having count star greater than or equal to 2, order by s.department. So let's read this kind of inside out. I like to start with the from clause. That's the table we're querying. In this case, it's the students table. And from the students table, let's look at the where clause. We're only going to look at students where s.gender equals F, female students. Okay? Now we're going to take the students, and in the group by clause, what we're saying is we want to group them by department. So I want female students grouped by department. I only want to look at those groups in the having clause that have 2 or more tuples. Okay? And then for groups that have 2 or more tuples that are for female gender, I want to compute the average GPA, the count of students that are female, and the name of the department. And I want to order the output by the department name. The keyword distinct in SQL gets used in 2 very different places. It gets used inside of aggregate functions, like the first example here, select count of distinct s.name. And it gets used right after this word select to remove duplicates from the output. These actually have very different meanings. So the first one, what we're doing is before we do the counting, we're going to remove all the duplicates of names. Okay, so if we had 10 people named Bob and 4 people named Mary, we would have only 2 distinct names, Bob, Mary, and then we would count and we would get 2. In the second case, we would count, we'd have 10 Bobs, 4 Marys, we'd get 14. And then before sending the output to the client, we would remove any duplicate rows. But there is only one row that would come out of that count query in the second case. It's got the value 14, so we would just return that 14. In essence, on an aggregate query, there are no duplicates, and the distinct keyword outside of the aggregate doesn't have an effect in this case. Here's an example query asking for the name and the average GPA from students grouped by department. What is this query asking for? Well, let's think about it for a minute. We're going to group things by department. And then for each department, we're going to say, what's the student name in that department? Well, this doesn't make sense, right? There may be many student names in that department. There probably are. Now, the average of s.gpa makes sense. But the select s.name doesn't make sense because there isn't a distinct name in a given department. So this query is actually illegal in SQL. And the reason it's illegal is you're using a column in the select list that is not in the group by clause, and it's also not nested inside of an aggregate function. That means there could be many names, and we don't have any way to boil them down to one value using aggregation. So this is an illegal query, and because the s.name field is neither in the group by nor in an aggregate function, it'll get rejected as an illegal query. So we've seen the SQL DML for single table queries, the basic DML, the select clause with the column expression list from a particular table, where predicate, that's look only at the rows satisfying the predicate, and optionally grouping by a list of columns. If we group, we can also have a having predicate on the groups that filters out groups that we're not interested in. Of course, we could always have order by if we want before we send it to the output, as well as limit. Okay. To summarize these simple single table queries then, and this is our first unit on SQL, the relational model has this well-defined query semantics. So all the queries that you type have a single meaning, and regardless of how the database management system chooses to implement them, whatever program it chooses to implement these declarative statements, the answer is well-defined. Modern SQL, that even SQL as defined in the 1970s up to now, extends the pure relational model, which actually we'll learn about later in this class, with some SQL-specific features. So duplicate rows is something that's in SQL, and we care about having 2 rows in a table that are exactly the same. We'll count them up specifically. The support for aggregate functions is something that SQL introduced that the original relational model doesn't have. And then the idea that we can order and limit the output, also kind of handy extensions in modern SQL. Typically, in SQL, there's more than one way to write the same query and have it mean the same thing. You can try any of the expressions that are equivalent, and the database is supposed to figure out a fast way to execute that query regardless of how you wrote it.